I'm Dr. Barry Bode. I am a researcher and consultant for NASA and an associate professor too at University of Southeastern Norway. I've spent almost 20 years utilizing and studying model-based systems engineering, and I've spent the last 9 years researching model-based systems engineering role in the digital engineering transformation. Today I'm going to be talking about MBSE in academia and why MBSE is important to industry in the digital engineering transformation. My talk has 3 objectives: to discuss briefly model-based systems engineering in academia, and then why model-based systems engineering industry and the role that it has in the digital engineering transformation, and then to talk a little bit about the digital engineering transformation in industry. First, it's important to understand why we model a system and why we teach model-based systems engineering. We have to acknowledge that it is not possible to model everything currently, but we do model to reason about the problem, or in our case, systems, to understand the complexity of the systems, and to communicate our systems to others. So what are the benefits of model-based systems engineering compared to historical ways of documenting systems such as Word documents and PowerPoint? In the Cozy Systems Engineering Handbook, version 4, they provide this list of benefits for MBSE. Improved communications between all development stakeholders. Increased ability to manage system complexity by allowing system model to be viewed from multiple perspectives. These perspectives are automatically generated in an MBSE tool, and the perspectives could include a customer perspective, an engineering perspective, a safety perspective. MBSE improved product quality through providing unambiguous and precise model of a system that can be evaluated for consistency, correctness, and completeness. An example of this would be units of measure, such as weight. You could ask in model-based systems engineering and check if all of the weight in a system is done by kilograms or pounds, something that is not easily done in PowerPoint. MBSE provides enhanced knowledge capture and reuse of information due to capture in standardized format. You can reuse parts of models in other models, or you can take one model and reuse the full model in another system, something that is much harder to do in a PowerPoint due to the lack of standardization in PowerPoint. And MBSE improved ability to teach and learn systems engineering fundamentals and system-specific designs. Again, when you're using model-based systems engineering, there is a standardized format. So learning systems and system engineering fundamentals, you can learn through a standardized format in a model-based systems engineering tool, and that has shown to improve the ability to teach and for students to learn the fundamentals of systems engineering and systems engineering specific designs. MBSE is a living representation of a system that can be used in simulation, verification and validation, maintenance, retirement, and legacy system development. The ability of being able to reuse the model-based systems engineering and to transfer your model-based systems engineering information into a simulation environment, a verification and validation environment, maintenance and retirement, legacy system development is something we'll talk about as it becomes very important in the digital engineering transformation. To successfully implement model-based systems engineering in an organization, there are 3 components that are needed. They are the modeling language, the modeling method, and the modeling tool. To some, this might seem a surprise. Many times when people think of model-based systems engineering, they just think of a tool, or they just think of SysML. But in reality, there are 3 things that are needed. The modeling language needs to be selected: SysML, UML, or UPDM. There needs to be the modeling method selected. There are many modeling methods, and this is just a list of some. The modeling tool needs to be selected. And again, there are many tools. These are just ones that I'm aware of, with some of the most popular tools being listed in this list. To successfully implement systems engineering and to get the benefits that we just talked about, all 3 of these components need to be thought about and selected. And the modeling tool many times goes with the modeling method and vice versa. The modeling method sometimes is developed for a specific modeling tool. It is also important to understand that each modeling tool implements the language of SysML uniquely, and therefore there might be slight differences in the way the SysML is implemented in the modeling tool. It is also important to note that many times, moving from one modeling tool to another, the system's model is not transferable easily. Therefore, if you are using multiple tools in your organization, it is possible to develop a model in one tool and not be able to have it easily transferred to another tool. It is also important to note that SysML is actually a very light language. And so in the modeling tool, there are many things that are not done due to the SysML standard, but have been implemented by the tool designers for model-based systems engineering. So why is MBSE a key enabler to the digital engineering transformation, which goes by many names? It also is the single source of truth, the digital engineering transformation, the digital twin. Those are just some of the names the digital transformation goes by. But MBSE is a key enabler because it provides semi-structured data that can be ingested and utilized for structured data. This structured data becomes very important in the digital transformation, as tool-to-tool integration has been identified as one of the key components to the digital engineering transformation and having a single source of truth or a digital twin. So what is the role of systems engineering in the digital engineering transformation? Systems engineering is where the design and the architecture of a system begins. It's where a system is birthed. In those initial days of designing and architecting a system, the data that is created needs to be able to be integrated, and it needs to interoperate with data that is downstream in manufacturing, in operation, in maintenance. There needs to be a continuous flow of data and being able to check that data for consistency and completeness throughout a system lifecycle. To do that, system engineers need to move away from unstructured data that's in documents and PowerPoints, and system engineers need to move toward structured data. This is not to say that documents and PowerPoints are going away. It is to say that the data and the information in those artifacts will be automatically generated from structured data. Again, to ensure that our system data is always consistent and complete, and that our data can be integrated and interoperate across the system lifecycle. This is the goal of the digital engineering transformation.